Hello everybody, myself Jyoti, and this is second lecture on atomic and molecular physics regarding Raman spectroscopy, of course. So in the last lecture we have studied about the general introduction of Raman spectroscopy. Here in this lecture we are going to study the quantum theory of Raman effect. So according to quantum theory, the radiation of frequency nu can be regarded as a stream of photons, each having energy h nu. So here when we I say that Raman effect, when a monochromatic beam of radiation is passed through sample, so we are not going to consider wave nature of whatever radiation we will pass. We will consider its particle nature, that is photon. So here we are basically going to consider light as a wave, light as a stream of photons, tiny little packets of quantum energy. So what happens when the radiation passes through a medium? When I say medium, I mean to say the sample which is under study. So we have a sample which is under study and we pass monochromatic radiation through it. So what will happen? So when the radiation passes through a medium, so when we say radiation consists of photons because we are dealing with quantum theory. So the photon collides with the molecules of the medium. मीडियम यानी सैंपल जो भी आपका है वो. So photons collide with the molecules of the medium, and this collision which takes place between photon and molecule, it can be elastic or it can be inelastic. So let us talk about what is elastic collision. When I say elastic collision, in this case the photons simply get deflected with their energy and hence the frequency remains unchanged. That means what is happening here? I have a photon, I have a molecule. Here this photon is not going to exchange any energy with this molecule. It will not give energy or it will not take energy for the molecule. So that basically in case of elastic collision, there is no interaction between the photon and the molecule. And hence the frequency of the photon, it will not change because it has not given energy or it has not gained energy, and it will remain same. What happens, and this is why, you know, when I say Raman effect, when we studied Raman effect, in case of Raman effect we get three lines. One which is having frequency same as that of the incident radiation. So why we are getting that? We are getting that because of elastic collision, because elastic collision mein photon is not exchanging any energy with the molecule, and that is how its energy or its frequency will remain same, and that is how we get the line with original frequency in Raman spectrum. Now what is elastic scattering of a molecule by a photon is also called as Rayleigh scattering. Now let us talk about inelastic collision. In case of inelastic collision, what happens? There is a exchange of energy between photon and molecule. So when the photon collides with the molecule can gain energy or molecule can lose energy, which is equal to delta E. ऐसा नहीं होता कि any amount of energy will be transferred from photon to molecule, because we are dealing with quantum theory. We know that quantum theory basically deals with discrete energy levels. So here when a molecule will gain energy, it will either absorb delta E energy from photon, or if a molecule is emitting energy or losing its energy, it will lose energy which is equals to delta E to the photon. So what is so just a second. How Stokes line and anti-Stokes lines are produced? So if the molecule gains energy, suppose the molecule it is in the ground state, so the molecule naturally it will absorb energy from the photon which is equals to delta E, where delta E it is nothing but the difference between the ground state and excited state, and it will go to the excited state. So if the molecule gains energy delta E, the scattered photon photon has given energy to the molecule, so photon का energy कम हो गया, so photon is having energy h nu minus delta E, and frequency, we know that frequency it is E by h, so frequency will be nu minus delta E upon h. So naturally the frequency of the photon is decreased. We know that the line for which the frequency is less than that of the incident radiation, it is nothing but Stokes line. So whenever the molecule gains energy, photon loses energy, photon का energy कम हो गया, photon का frequency कम हो गया, and that gives rise to Stokes line. Now, on the other hand, if the molecule is already in the excited state, it will come to the ground state by losing energy delta E to the photon. And the scattered photon will have more energy, h nu plus delta E. Naturally, it will have more frequency, nu plus delta E upon h, and this will give rise to anti-Stokes line. So this is how Stokes line and anti-Stokes lines are formed. So one more thing is here. Just a second. So what is the contribution of temperature to energy of photon? We know that temperature plays an important part in energy because E, it is nothing equals to kT. So temperature बढ़ेगा तो energy भी बढ़ेगा. Now here when we are studying Raman effect, what we are assuming is the temperature of the substance or sample under study is constant, so that there is no change in the kinetic energy of the molecule because of the temperature. We are assuming that ki we have maintained the temperature constant, so whatever molecule is gaining energy or losing energy, it is because of the photon, not because of the temperature. Now you must be remembering that in the last lecture when we studied the characteristics of Raman effect, that time I told you that Stokes lines are more intense than anti-Stokes line. Why it is so? So when we talk about Stokes lines, how Stokes lines are formed? Stokes line is formed when a molecule is in the ground state, it absorbs a photon, it goes to the excited state. So then we get Stokes line, and whenever a molecule is already in the excited state, it loses energy to the photon, and in that case we get anti-Stokes line. Now when we talk about vibrational state, we have studied in the spectra of diatomic molecules that in case of vibrational state, most of the molecules, they are in the ground vibrational state. And here, as most of the molecules, they are in the ground vibrational state, the tendency to go from ground state to excited state by gaining energy from the photon, it will be more as compared to the probability of transition from excited to ground state. And that is how we get more we have more photons which are contributing to Stokes line, and that is how Stokes line is more intense as compared to anti-Stokes line. Second, we have also studied that Stokes lines and anti-Stokes lines are symmetrically placed on either side of the unperturbed line. This was the characteristics which we studied in the last lecture. Why it is so? Now, since the energy gained by a molecule to go from lower to higher state, it is delta E, and also the energy lost by a molecule to come from excited state to ground state, that is also delta E. So the same energy is required. So energy gained by a molecule or energy lost by a molecule, it is same, and that is how Stokes line and anti-Stokes lines are symmetrically placed on either side of the unperturbed line. Unperturbed line, unmodified line, parent line, they all mean the same thing. So thank you so much. So we have discussed quantum theory of Raman effect in this lecture. In next lecture we will study classical theory of Raman effect. Thank you so much.